You blink somewhere between 15 and 20 times every minute. That is not a guess. That is a measurement taken in laboratories across decades of research, confirmed in hundreds of subjects, consistent enough to be called a biological constant, 15 to 20 times per minute. Do the math across a full waking day, and you arrive at a number that should stop you cold. Somewhere between 14,000 and 19,000 blinks every single day for your entire life. Now here is the part that is harder to sit with. Each blink lasts between 150 and 400 milliseconds. Add those up, stack them end to end, and you find that you spend approximately 30 minutes of every day in complete darkness, not asleep, not resting. Eyes open, functional, pointed at the world, and blind. 30 minutes every day that your brain erases so completely you have never once noticed them. Keep that number in mind. We are going to come back to it, and when we do, it will mean something very different than it does right now. So what happens if the blinks stop? Not for a moment. Not because you are staring at a screen. Permanently. What if, starting right now, every human being on Earth simply stopped blinking? The question sounds almost trivial. It sounds like a minor inconvenience. It is not. Let us set the rules clearly. Every human being alive loses the ability to blink. The eyes remain open, the eyelids do not move, nothing else changes. No disease, no accident, no surgery, just the blink gone. What unravels from there is more complex, more layered, and in the end, more strange than almost anything you would predict. The first thing you would feel is dryness. Not dramatic dryness, not pain, not yet. Just a faint, nagging discomfort, like the early seconds of forcing your eyes open during a staring contest. Most people have felt that sensation. They know the mild sting, the slight blur at the edges of vision. They also know what immediately follows. A blink. The relief is instant. The moisture is restored. The world snaps back into focus. In a world without blinking, that relief never comes. The surface of your eye is coated in a thin film called the tear film. It is not just water. It has 3 distinct layers. The innermost layer is a mucin layer, a sticky gel that anchors the whole structure to the surface of the cornea. Above that is an aqueous layer, mostly water, which carries oxygen and nutrients. On top is a lipid layer, a thin coat of oil produced by tiny glands along the edge of your eyelids, and its job is to slow evaporation. Together, these 3 layers form a structure about 3 micrometers thick. That is roughly 1/30th the width of a human hair, and without blinking, it begins to fall apart in seconds. Researchers have a test for this. It is called the tear film breakup time test, and what it measures is exactly how long the tear film holds together on an unblinking eye. The average result is 7 to 10 seconds. That is not minutes. That's the length of a slow breath. Within 7 to 10 seconds of your last blink, the tear film develops weak points. Within 30 seconds, it is fragmenting. Within a few minutes, significant patches of the corneal surface are exposed directly to the air. Here is why that matters in a way that goes beyond discomfort. The cornea is the only tissue in the entire human body that has no blood vessels. None. Every other tissue in your body receives oxygen through blood. The cornea receives its oxygen directly from the tear film and from the air itself. It is essentially breathing through its surface. Remove the tear film, and the cornea begins to starve. Not slowly, not gradually, immediately. The corneal cells begin to swell. Fluid floods in where it should not be. The cornea, which is normally as transparent as glass, begins to cloud. This condition is called corneal edema, and once it begins, it cascades. The cloudiness deepens, vision blurs, then it distorts, then it dims. And without intervention, within hours, it is gone. That is not speculation. There are people who live this. Patients with facial nerve palsy, damage to the nerve that controls the muscles of the face, sometimes lose the ability to blink on one side. With aggressive treatment, artificial tears applied every few minutes, careful monitoring, most can protect their vision. Without that treatment, corneal ulceration, open sores on the surface of the eye can begin within 24 hours. Severe vision loss can follow within 48 to 72 hours. Permanent blindness is not a distant risk. It is a rapid documented outcome. In a world where no one blinks, there are no artificial tears sufficient to cover 8 billion people. The infrastructure does not exist. The materials do not exist. Every person on Earth would begin losing their vision within hours. That seems like the end of the story. The eye fails, the cornea clouds. Humanity goes blind, catastrophic, irreversible, complete. But that is not the dangerous part. Because even if you could somehow save every eye on Earth, even if every cornea stayed perfectly moist and clear, something else would still be breaking. Something deeper. Something most people never think about, because it operates entirely below the level of awareness. Here is what is actually happening every time you blink. Your brain knows the blink is coming before it happens. It sends a signal ahead of time, a kind of warning shot to the visual cortex, the part of the brain that processes everything you see. That signal says, pause, stop processing, we are going dark for a fraction of a second. And the visual cortex obeys. It suppresses its own activity. It goes quiet. The blink happens. The eye is closed. No light enters. And the visual cortex does not even notice, because it already stopped looking. This is called blink-induced suppression, and it is one of the most elegant pieces of engineering in the entire nervous system. When the eye opens again, the brain does not simply resume. It stitches. It takes the image from just before the blink and the image from just after the blink, and it welds them together into a continuous, seamless experience. The gap is erased. The darkness never registers. You perceive a smooth, unbroken world, flowing forward in time without interruption. Every single blink is a cut in a film reel that you never see. The editor is your brain, working at a speed no human technician could match, 15 to 20 times per minute for every waking hour of your life. Now think about what happens when the cuts stop. The brain's visual cortex, which has been receiving carefully interrupted data since you first opened your eyes as an infant, suddenly begins receiving something it has never processed before, a continuous, unbroken stream of raw visual information, with no pauses, no resets, no stitching points. It is like a film projector that was built to advance one frame at a time, suddenly being fed a single endless frame that never changes. And this is the part most people never think about. The brain does not just process what it sees, it uses blinks as punctuation. Each blink is a moment where the brain's background systems, the networks responsible for attention, for emotional processing, for memory consolidation, have a fraction of a second to do their work. Researchers have found that blinks are tied to something called the default mode network, a set of brain regions that activate not when you are focused on a task, but in the gaps between tasks. The moments of internal processing that you barely notice but cannot function without. Blinks give the brain 14,000 tiny pauses per day. Brief as they are, they appear to be when the brain performs attentional resets, clearing the short-term buffer, preparing for the next moment of visual input. Remove those pauses, and you do not simply get more sustained attention. You get the opposite. The attentional system begins to saturate. Signal bleeds into signal. The brain loses its ability to separate one moment from the next. Let us stay here for a moment. Think about what that actually means. Your experience of time is not continuous. It feels continuous. But that feeling is constructed, assembled from discrete chunks, the way a film is assembled from still frames running at 24 per second. The brain segments experience. It packages moments into units that can be stored, recalled, compared, and acted upon. Without that segmentation, memory formation would begin to fragment, not like forgetting, like the inability to form distinct memories at all, because the brain can no longer identify where one moment ends and another begins. The psychological consequences would not arrive all at once. They would build. First, a subtle difficulty concentrating, a creeping inability to hold attention on anything for more than a few seconds. Then a growing sense of visual overwhelm, as though the world is too much, too fast, too continuous to make sense of. Then, as the hours passed, something harder to name, a dissolution of the ordinary sense that time is moving in a direction you can follow. But there is something else blinking does, something that connects the eye to one of the most fundamental systems in the brain. And this is where the story turns strange in a way that no one fully expected. Blink rate is one of the most reliable indirect measures of dopamine activity in the human brain. Dopamine is the brain's signal for motivation, for reward, for movement, for the feeling that something matters. And the connection to blinking is not subtle. Patients with Parkinson's disease, which devastates the dopamine system, blink as few as 1 to 4 times per minute, a fraction of normal. Patients with schizophrenia, a condition associated with dopamine excess in certain brain pathways, blink far more frequently than healthy individuals. Neurologists use blink rate as a clinical proxy, a window into the brain's dopamine status that requires no blood test, no scan, just observation. The mechanism behind this connection is still being studied, but the implication is striking. Blinking is not separate from the dopamine system. It is entangled with it. The rhythm of the blink is, in some measurable sense, a rhythm of the brain itself. Remove the blink entirely, and you are not simply removing a motor behavior. You are removing a signal that the brain uses to calibrate its own internal chemistry. What downstream effects that would have on motivation, on emotional regulation, on the basic sense of reward and meaning are not fully understood. But the direction is clear, and it is not toward stability. So here is where we stand. In a world without blinking, within the first few minutes, the tear film fails. Within hours, corneal damage begins. Within days, billions of people are losing their vision. Simultaneously, from the first second without a blink, the brain's visual processing, attentional systems, memory formation, and neurochemical calibration are all degrading together, layered failures cascading through systems that were never designed to operate independently of each other. And now we arrive at the reframe. Think about that number again. The 30 minutes of daily blindness. You were probably holding it as a strange, unsettling fact, evidence of how much your brain hides from you. A measure of what you do not know about your own experience. 30 minutes of darkness, quietly erased every day. But look at it differently now. Those 30 minutes are not a flaw, they are the mechanism. The blink is not an interruption of vision, the blink is the engine of vision. The darkness is not something that happens despite seeing, the darkness is what makes seeing coherent. Every smooth, continuous, meaningful image of the world that you have ever experienced, every moment that felt like an unbroken stream of reality, was built inside those gaps, assembled in the dark, stitched together by a brain that had exactly 150 milliseconds to construct the next frame of your life before the eye opened again. You have never seen the world continuously. You have only ever seen the world in pieces, and a part of you, working faster than thought, has been quietly building it into something whole, every waking hour for your entire life. The question that remains, and that no one has fully answered, is whether the construction is so practiced, so deep, so woven into the architecture of the brain, that without the blinks, the world you see would not simply go dark. It would go strange first. Make sure to like and subscribe, and comment if you liked this video. We look forward to seeing you next time.